Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Jordan Fiasco 8822. Thanks for the suggestion, Jordan. You asked, what is fire actually made of? Fire is one of those things we think we understand until we try to explain it and realize we sound like a medieval wizard yelling, hot, glowing stuff. Today, we're pulling the curtain back on this dramatic, sizzling little phenomenon. Stay tuned as we break down what fire actually is, why it glows, why it dances, and why it's basically chemistry throwing a tantrum. Right here on Explaining Everything. Let's clear something up immediately. Fire is not a solid, not a liquid, and not a gas. It's actually plasma's rebellious younger cousin. Or in scientific terms, it's a physical process made of hot, glowing gases and ionized particles produced during combustion. When something burns, wood, gas, that one popcorn kernel you always overestimate, the heat breaks apart molecules. Oxygen swoops in, bonds with some of the freed atoms, and a fast, self-sustaining chemical reaction begins. Combustion. This reaction releases heat, light, and a bunch of excited particles. These particles get so energized, they emit light. That glowing light is what we see as fire. So fire isn't an object. You can't pick it up. You can't bottle it. You can't take it home like a souvenir. Fire is a visual side effect of energy escaping the scene of a chemical crime. If we zoom in, not too close, we like our eyebrows. A flame is a chaotic mix of hot gases, like carbon dioxide and water vapor, unburned fuel particles, free radicals, which are atoms and molecules mid-reaction, ionized particles, which give the flame some plasma-like behavior. And depending on the fuel and temperature, different parts of the flame have different colors. The blue at the base of a flame, that's the hottest part, where oxygen is plentiful and molecules are fully combusting. The yellow-orange part, that's soot particles, tiny carbon bits, getting heated until they glow like microscopic light bulbs. The red edge, that's the cooler region, where the reaction is running out of energy like a phone on 2%. So fire is basically a chemistry rave, with particles heating up, glowing, and colliding at speeds that would make any nightclub jealous. You've probably noticed flames don't just sit there. They wiggle. They dance. They do that weird snake thing when you blow gently at them. So what's up with that? Flames move because hot air rises. As the gases in the flame heat up, they expand and become less dense, shooting upward. Cooler air rushes in at the bottom, feeding the reaction with fresh oxygen. That circulation, hot gases rising, cooler gases entering, makes flames wobble and twist. It's not alive, but fire does respond instantly to its environment. A small breeze, it leans. A sudden burst of oxygen, it grows. No oxygen, it dies like a sad campfire, ending the night early. Scientifically speaking, fire is a self-optimizing chemical reaction constantly adjusting to find the oxygen it needs. Emotionally speaking, it behaves like the most dramatic member of the periodic table. Now, let's talk about the heat, the part that turns pizza into charcoal when you just checked your phone for 30 seconds. The heat from fire comes from breaking chemical bonds and forming new ones. When fuel and oxygen react, they rearrange into new molecules like CO2 and H2O. The new bonds release energy as heat and light. That heat continues feeding the reaction, allowing more fuel and oxygen molecules to break apart and recombine. This is why fire spreads. It keeps generating the heat required to trigger more combustion. Fun reality check. Fire spreads not because it wants to, but because heat keeps creating the conditions that allow new parts of the material to ignite. Fire doesn't have feelings. Fire just has momentum and zero boundaries. At the end of the day, fire is a glowing mix of hot gases, excited particles, and energy released during combustion. It's not an object. It's not a substance. It's a brilliant, chaotic light show created when fuel meets oxygen and heat gives them no choice but to break down and freak out. It's chemistry expressing itself loudly, dramatically, and sometimes a little too enthusiastically, like a reaction that doesn't know its own volume knob. So next time you stare into a candle flame and think, wow, that's pretty, just remember, you're basically watching air, gas, and energy collectively scream, sparkle, and rise into the sky like it's the season finale of a science drama. If you enjoyed this deep dive into those spicy, glowing light, don't forget to like, subscribe, and that, friends, is what fire is actually made of. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.